All right, week 12, set 2, SWYK 2, here we go. We want to take these polynomials that are in factored form, and we want to write the polynomial in factored form. We're starting out with standard form. I'm getting all mixed up, too many videos. Anyway, so we're starting out with standard form. Why isn't that writing? Right, here's our standard form, decreasing order of exponents. And we want to write it in factored form. Now, to factor it means to divide. That's really what you're doing here, is dividing. Well, first rule of all factoring is look for a GCF. In this particular case, the common term between everything is an x. You can take an x out of every one of those. Now, when I say take out an x, maybe I should zoom in a little bit here. What I'm really talking to you about, so you can see that I put the x on the outside, and then I put parentheses, and I'm like, okay, what's going to happen? What's going to be left on the inside? What I'm doing is I'm going through each one of these terms, and I'm saying, if I divide that by x, what am I left with? And it's x squared. If I divide that by x, I'm left with negative 2x. If I divide that by x, I'm left with negative 24. Now we're down to factoring that you normally know how to do, right? Where you're breaking this down. It's a process, it's division. You're breaking it up into the product of two things, this parenthesis and this parenthesis, and you're looking for things that multiply together to give you negative 24, but add up to negative 2. Of course, one of them has to be positive and one has to be negative to get negative 24. And when you multiply or add them together, you end up with negative 2x. All right? So we know we're correct. This answer that I have in the red box is the correct answer to this question. It is factored. In not only is it factored, but it's factored completely because every one of the terms is a linear term. The farthest you can break things down is a linear term if, I do say if they have real solutions. And we would want to say rational solutions, to be quite honest. Now, there are irrational solutions and factors that have irrational numbers. I think we're going to stay away from that for now. But, okay, next. Stop doing that. Seriously, I wanted to move the screen. Sorry, it's my fault. Okay, now I look for a GCF. In this case, the GCF is, now, be careful. When it's got a negative in front of it, that's a good clue that you should take the negative out with it. Okay? And it's each one of those you can divide by negative 4x. So we're literally going through and dividing by negative 4x to every one of those terms and seeing what's left. And what we ended up with was x squared plus 5x minus 24. So once again, we're coming up with factors of negative 24. This time, instead of adding up to negative 2, they're adding up to 5. So I had to think through that, and I came up with positive 8 and negative 3. Okay, but that's the factored form. Negative 4x, that's out in front. And then you've got these other terms. Does it matter what order they're in? No. I mean, I could just as easily have. We do like to keep the negative 4x, the GCF, out in front. It's not a crime if you don't, but it tends to get a little bit messy because people start thinking, well, are you subtracting something or adding something? No, it's just you're multiplying by it, but, something like that would be great. Okay. Next, find the zeros of the function. All right, the zeros, remember, are found from the factors. So we're still going to go through the process of factoring, right? Look for a GCF. In this case, it's 7x. And then divide everything by 7x to figure out what goes inside the parentheses. We get x squared and a minus 1. Oh, look, a difference of perfect squares. That can be factored further, right? We take the square root of this and the square root of that, and one's a plus and one's a minus, even though I said that in backwards order. So now we have it factored. What do we do now? We take the factors and we set the factors equal to 0. So 7x is one of the factors. It's set equal to 0 because you know what? let me make this perfectly clear. Well, this is just like what we did before with the quadratics, so you should be familiar with this. Set each one of these factors equal to 0 and solve, right? You're going to divide by 7. Okay, so that means that 0 is one of our x-intercepts. And of course, we're going to add 1 and get 1. And of course, we're going to subtract 1 and get negative 1. So those are the 3 answers, okay? Now, how often did those things occur as a factor? That's that term multiplicity that we saw before. How often did you see 7x? How often, here, let me use my eraser. The multiplicity is found by the exponent. And it looks like the exponent here is a 1, and the exponent here is a 1, and the exponent here is a 1. That's why they didn't write them down. Well, so all the multiplicities are 1s. If those exponents were higher, then that means the factor would occur more than once. So we chose the number 0, 1, and negative 1. It doesn't matter what order they're in. Our zeros of multiplicity 1, so that was letter choice B. Okay, next. Slightly different topic, but it's along the lines of graphing polynomials. Okay, slide my face over. Find the relative maximum and relative minimum of the graph of the function. Now, just so you're aware, a relative maximum is the y value, the y value at the top of a hill. So when you're looking at these, obviously I'm trying to refer to this as a hill, and at the top is a y value. At the top of that little hill. Now, they use the word relative because absolute maximum is a different term. In fact, this particular graph has no absolute maximum. It does, however, have a relative maximum. Relative just means it's local. Sometimes they use the word local because inside of a small area, it does have a high point. Okay? And so that's where we get this idea. It's the y value at the top of the hill. Okay? And how did I find out that 4.27 was the y value at the top of the hill? Let me show you. I'm using one of my favorite graphing programs online called Desmos.com. It's Desmos.com/calculator. And if you have a graphing calculator, you could also do this with the graphing calculator. You could use the y equals feature. If I need to lock this in place, please. So we could use the y equals on a graphing calculator, and we could actually graph this, all right? And by graphing it, now I will say that one thing I love about the Desmos.com, which you cannot get on a graphing calculator, obviously, you can change things, right? You can zoom in and zoom out, where you grab onto it and shrink it, all that good stuff. You know how to use technology. But one of the things you might not know how to do is grab 2 points. If you take, I did it wrong. Grab 2 points on the, let's say, the x-axis. Why isn't it? And it should light up light blue. When it does that, then you can stretch or shrink only the x-axis. Or likewise, we could do this with the y-axis. In other words, you could get the picture that makes sense or is easier to look at. On a graphing calculator, you would need to go to you can see at the top of the calculator, it'll say trace. And above that, it says calculate. And so, in other words, we would want to calculate a maximum. So there's a little bit more to it on a graphing calculator. But I think you would be better off just to use the Desmos.com/calculator. And you would, I better actually come here. Don't slide over. You can put your cursor anywhere on this thing, right? And it shows you the exact x and y value. But what you're really interested in is this little gray dot right here. click on it and you can see. And then as I wrote down, I actually wrote down that Y value of 4.27. They wanted me to round to the hundredths place, so I rounded to the hundredths place. You can also see the X value. So the X value is where, the Y value is what. Now, what do I mean by that? They're going to ask you, where does the relative minimum occur? All right? The relative minimum is occurring at negative 1.72, and I really kind of need to, okay. The correct answer to this question is obviously letter D. But the Y value is right there. The where is the X. What is the Y? What is the actual relative minimum? That's the Y value. Okay, now they're going to ask me for the relative minimum. Well, that is the Y value at the bottom of the valley. And if I come back over here to Desmos.com and highlight that point at the bottom of that valley, I get negative 0.42. So, and it occurs at 0.39. So I can come back here and I go, oh, negative 0.42 is the Y value. It occurs at an X value of 0.39. That's your where. Where 0.39, what is it? Negative 0.42. Okay, so that's relative maxes and mins. Those are features we won't be dealing with tons, but I thought I would point that out to you. Okay, I do have a story problem to go through with you, which is why this video is way too long. I didn't think it was going to be that long, so I'll try to go through this quickly with you. We're taking a piece of sheet metal, or it could be cardboard. It's a rectangle, and we are going to cut a certain amount of material out of the corners, and we're going to fold up the edges and make what we call an open-topped box. Okay? Now, if the original dimension is 24 inches, and you take an X off of this end and an X off of this end, you have taken two X's off of the 24, which means that the bottom edge, the lengthwise bottom edge of the box is going to be what we call 24 minus 2X. Now you're going to do the same strategy over here with the width. You're going to take an X off of both of those ends, so that makes the width 16 minus 2X. And if you fold up the edges, that little X that you decided, that distance that you cut out of the corner, that becomes the height of your box. Okay, so we basically just chopped these little corners out, got rid of them, and then we folded up those edges along the red dotted lines and made a box. That's the idea here. Well, how do you find volume? Volume is found by length times width times height. Length times width times height. Well, you know that. You've studied volume of a rectangular solid from geometry class, right? Volume equals length, width, and height. Well, if your length is 24 minus 2x and your width is 16 minus 2x and your height is x, you'll notice I put them in kind of reverse order. Big deal. I decided to multiply these two together first, and when I did that, I got the 4x squared minus 80x plus 384, and then I distributed the x last. Seems pretty straightforward. Just doing that. And so that's what I ended up with for my volume. Okay? The nice little equation here. Okay, now I want to look at the graph, because we want to find out the maximum volume that I should cut out of the corners, or I should say, what's the maximum X amount that I should cut out of the corners to make the biggest volume box. All right? So we actually take this thing and we graph it. I'll pause it and go graph it. Maybe. Okay, so I typed in my equation, but man, I can't see what's going on here. Well, remember how we would have to zoom out? Now I'm starting to see some of it, but it's really hard to kind of zoom in on that x-axis, so I had to do that first, and then now I'm zooming in on this, and now I'm getting a better looking picture, and I can bring it over, kind of shrink it up, see what's going on with this thing. All right, so here's my polynomial, right? Does it make sense to have negative numbers? Can you cut negative amounts out of the corners? No. So that means none of this part of the graph makes any sense. Can you have negative volumes? Nope, so none of that part makes any sense. Can you have volumes that go to infinity? No, you can't have that. So really, this chunk of the graph is the only part of the graph that makes any sense to cutting little squares out of the corners and, you know, creating a positive volume. So I would really like to know where that top point is. Whoops. So let's come here and, yeah, there it is. So if we cut out 3.1, they wanted me to round to the tenths, 3.1 inches out of the corner, we will come up with 540.8 cubic inches. So that information is what I used to answer the final question. The maximum volume is 540.8 and is generated when I decide to cut 3.1 inches out of the corners. So anyway, here's the graph, and you know, just like we talked about before. Plus, if you think about it, it's got a leading coefficient of +4, so the right-hand behavior has to be up. So there's no way it could be that one or that one. And then it's got an odd degree, so the left has to be opposite. Well, this goes up and up, so that disagrees. That has to be the graph on the far left. Okay, sorry this video was so long, but I don't think the problems will take you that long. It's just a matter of explaining more things than I thought I could do in a shorter amount of time. All right, have a great SWYK and assignment. See ya. Make sure you guys come get help from me when you can, instead of just acting, you know, instead of just struggling with things.